Have you ever pondered the future of our planet Earth, not just years or centuries ahead, but millions of years into the future? Imagine our home not as the familiar blue and green globe we know today, but as a planet in flux. A planet whose very skin is constantly shifting, changing, and evolving. This is the reality of Earth's geology, a reality dictated by a concept known as plate tectonics. Think for a moment about a jigsaw puzzle, each piece different in shape and size, fitting together to form a complete picture. Now, imagine that these pieces are not static, but in constant motion, sliding past, colliding with, and pulling away from each other. This is how the Earth's crust behaves. It's a patchwork of large and small pieces known as tectonic plates that are always on the move. These tectonic plates don't just carry our continents, they shape them. Over millions of years, their relentless motion has repeatedly brought the continents together, forming massive landmasses we call supercontinents. Earth has seen several of these supercontinents form and break apart over its long geological history. The last known supercontinent, Pangaea, assembled some 300 million years ago. It was a titanic landmass, a monolith that stretched from pole to pole. But, like its predecessors, Pangaea was not to last. Plate tectonics saw to its demise, tearing it apart and reshaping the continents into the configuration we recognize today. And yet, this is not the end of the story. Far from it. For the wheels of plate tectonics grind on, driven by the Earth's internal heat engine. They will continue to move, to collide, to fracture and reform. Given enough time, they will once again bring the continents together into a new supercontinent. The Earth's crust is not a static entity, but a dynamic, ever-changing canvas continually sculpted by the forces of nature. So, as we look to the future, we must prepare ourselves for a planet that will look very different from the one we know today. A planet in flux. Imagine the Earth as a giant recycling machine, a process taking hundreds of millions of years. Now let's delve into the fascinating concept of the Supercontinent Cycle. This cycle is a grand pattern of the Earth's crust breaking apart and coming back together. It's like Earth is playing with its own set of cosmic Lego blocks, constantly breaking and rebuilding. Our planet has been through this cycle several times already, with each round forming a supercontinent. These are gigantic landmasses where all or most of the Earth's land is clumped together in one vast expanse. Picture a world where you could walk from one end of the land to the other without ever crossing an ocean. Let's take a trip back in time, about 1 billion years, to meet Rodinia, one of Earth's previous supercontinents. It's believed to have been located in the southern hemisphere, and its breakup is said to have led to a global ice age. Fast forward a few hundred million years, and we meet Pangaea, the most recent supercontinent, and perhaps the most famous. Pangaea was fully formed around 300 million years ago, and its existence is well documented through geological evidence. Fossils found on widely separated landmasses, similar rock formations across oceans, and the puzzle-like fit of continental shelves are all clues that point to this supercontinent. So, how do scientists identify this cycle? It's all about understanding the Earth's crust and the forces that shape it. The crust is broken into tectonic plates which are constantly moving due to the Earth's internal heat and gravitational forces. These plates collide, pull apart, and slide past each other, causing the crust to break and reform. This cycle of separation and reunion has been repeating for billions of years, a dance choreographed by the Earth's internal heat and gravitational forces. It's an incredible process that reminds us of the ever-changing nature of our planet, a testament to its dynamism and power. So, what does the future hold for our continents? Meet Pangaea Proxima, our future supercontinent. Imagine, if you will, the world map as you know it now, but then give it a little shake, like a snow globe. Over a period of about 250 million years, the continents we know today will set off on a grand journey across the globe, eventually coalescing into a new supercontinent known as Pangaea Proxima. How do we know this? Well, scientists use the study of plate tectonics, the movement of the Earth's crust, to predict the future of our continents. This is no fortune-telling, mind you. It's a science of studying the past and understanding the present to forecast the future. So, let's take a peek into this distant future. Africa, the cradle of humankind, will collide with Europe, closing the Mediterranean Sea. Imagine the African and European continents like two titanic icebergs, drifting towards each other and finally crashing together. The impact of this colossal collision will thrust up new mountain ranges taller and more majestic than the Alps or the Himalayas. Now let's turn our gaze towards the Americas. They will embark on a westward journey, sliding past the icy wilderness of Antarctica and finally colliding with the vibrant and diverse lands of Asia. This monumental merger will create a whole new landscape, with the Rockies and the Andes locking arms with the Himalayas and the Siberian ranges. But it's not just about land. The shifting continents will also dramatically reshape our oceans. The Atlantic will widen, while the Pacific will shrink. New seas will be born, and old ones will disappear, forever altering the marine habitats and the creatures that call them home. The face of our planet will look drastically different, with new mountain ranges, landforms, and seas. This is the world of Pangaea Proxima, a testament to the ever-changing nature of our planet. It's a mind-boggling thought, isn't it? But remember, change is the only constant, even when it comes to the continents. The formation of a supercontinent is not just a grand geological event. It has profound effects on life and climate. This is where the story of supercontinents gets really interesting. Imagine the world as a giant puzzle, with continents as its pieces. Over millions of years, these pieces drift and collide, forming supercontinents. These massive landforms don't just sit pretty on our planet. They stir the pot of life and climate in significant ways. Let's talk about evolution first. The merging of continents creates diverse habitats, from lush forests to sprawling deserts. This variety of environments leads to a burst of biological diversity as species adapt and evolve to their new homes. However, these changes can also lead to the extinction of species that can't adapt quickly enough. Moving on to climate. The formation of a supercontinent can drastically alter the Earth's climate. When a supercontinent forms near the equator, it can create a hotter, drier climate. On the other hand, if it forms near the poles, it can trigger an ice age. This shift in climate can also influence the evolution of species, pushing them to adapt or risk extinction. Finally, let's touch on the Earth's magnetic field. The drifting of continents can affect the flow of molten iron within the Earth's outer core, which generates our planet's magnetic field. Changes in this flow can cause the magnetic field to weaken, flip, or even disappear temporarily. Now, these are just a few examples of how the formation of a supercontinent can influence our planet. It's a complex process with far-reaching effects that we're still trying to fully understand. But one thing's for sure, the formation of supercontinents has played a crucial role in shaping the world as we know it. So, as we anticipate the formation of the next supercontinent, Pangaea Proxima, in about 250 million years, we can expect a significant shakeup in our planet's life and climate. The formation of Pangaea Proxima will undoubtedly usher in a new era of biological diversity and climatic change. While we won't be around to witness it, envisioning the future of our planet gives us a sense of perspective. It's a journey through time, stepping a staggering 250 million years into the future. The Earth, as we know it, will have transformed into another supercontinent. Our continents, ever shifting, will have danced across the globe, converging into one massive landmass. This isn't a wild prediction, but a logical conclusion drawn from a deep understanding of geological phenomena. What we've discussed today isn't just about the Earth's past or its future, it's about the here and now. It underscores the dynamism of our planet, the ceaseless evolution that shapes our world. It helps us appreciate the intricate ballet of geological forces that have been at play since time immemorial.